Did you know that someone correctly predicted the properties of countless undiscovered elements? What does a textbook have to do with the invention of the periodic table? Find out more as we dive into the life of the genius chemist Dmitri Mendeleev. Dmitri Ivanovich Mendeleev was born on February 8, 1834, in a small village in what is now Tobolsk, an area in western Siberia. His father was named Ivan Pavlovich Mendeleev, who taught in two gymnasiums, the equivalent of Russian high schools. Ivan's father was a Russian Orthodox priest. On the other side of the family, Dmitri's mother, Maria Kornilova, descended from Tobolsk conversions. Myths would state that the family's roots could be traced to Central Asians. Dmitri was the youngest of 17, 14 of which survived infancy. His father became blind and lost his teaching post, but the young Mendeleev attended the Tobolsk Gymnasium at age 13 nonetheless. By 1849, when Mendeleev was 15, his mother took him to Moscow, recognizing his talent and attempting to get him enrolled in Moscow University. When that failed, the pair, along with Mendeleev's grown siblings, moved to St. Petersburg, and Mendeleev attended St. Petersburg University. His mother died soon after, and Mendeleev graduated in 1855. After that, he caught tuberculosis, moved to Crimea, or now Ukraine, and went back to earn his master's degree in 1856 at the age of 22. As if that wasn't enough, he studied at the University of Heidelberg for 2 years, with the likes of Robert Bunsen, Emil Erlenmeyer, and August Kekule. He also attended the International Chemistry Conference held in Karlsruhe, southwestern Germany, in September 1860. He finally returned to St. Petersburg in 1861, securing a professorship at the Technological Institute in 1864. Mendeleev taught at his alma mater, St. Petersburg University, from 1867. Ironically, it was a lack of a textbook that led Mendeleev to create his famous periodic table. After Mendeleev wrote a textbook on organic chemistry in 1861, he had to teach inorganic chemistry but couldn't find a suitable textbook until he wrote one in 1868. Composing the textbook's chapter on halogens, Mendeleev started to compare and contrast halogens' properties to alkaline metals before he moved on to the alkaline earths. He then claimed that atomic weights would arrange the groups of the elements while he investigated the properties of valence. In a series of bold moves that threatened the future of his periodic system, Mendeleev predicted the existence of scandium, which he called ecoboron, gallium, ecoaluminum, germanium, ecosilicon, rhenium, ecomanganese, or technetium, or deutmanganese. He also filled in the spots of other undiscovered elements with question marks, elements which would almost all become to reality. Challenging scientific convention, Mendeleev also changed the properties of multiple different atoms, doubling both the valence and atomic weight of uranium to 6 and 240, of which both are correct or nearly correct. The actual valence for uranium is 6, and its atomic weight in its most stabilized form is 238. He also assumed that the atomic weight of adjacent elements would be monotonically increasing, which would be false, especially with the case of tellurium and iodine. He published and presented his system under the name Tentative System of Elements, naming unknown elements with Sanskrit prefixes. Not only did Mendeleev organize all the elements into one table, he also found absolute boiling points of different chemical compounds in 1860 during his stay in Germany. Later on, he investigated the elasticity of gases and published his work on a topic with a textbook. In addition to his profound contributions to the periodic table and chemistry, Mendeleev also modernized Russia, bringing back with him on his 2-year trip to Western Europe and the metric system. Mendeleev revolutionized and attempted to increase Russia's technology and power. After decades of insistence and pleas, the metric system was introduced and made optional by 1899, and it completely replaced the old imperial system by 1918, when the Soviet Union made it mandatory. The petroleum industry also got its start under Mendeleev, who traveled to Philadelphia in the 1870s and borrowed technology from John D. Rockefeller's Standard Oil Company during his time in western Pennsylvania. He also studied the composition of crude oil and the differences between the oil in western Pennsylvania and the Caucasus Mountains. As a result, by 1883, oil production had increased by 20 times compared to 1871. Mendeleev had also invented a new type of gunpowder commissioned by the Russian Navy in the 1890s. With these achievements in mind, it is important to note that he was able to work on and make contributions in both science and industry and achieve one of his main dreams, to integrate Russia with the rest of Europe. Mendeleev married Feodosva Leshcheva in 1862, but then fell in love with Anna Popova in 1878, marrying Popova in March 1882 and divorcing Leshcheva 1 month later. One of his daughters was the wife of a famous poet, Alexander Blok, and the son took part in the Eastern Journey of Nicholas II. He was awarded the Davy Medal in 1882 and the Copley Medal in 1905 from the Royal Society in London, in addition to being awarded the Faraday Lectureship Prize received in 1889. After he resigned from his post in St. Petersburg University in 1890, he was elected a foreign member of the Royal Society in 1892 and appointed director of the Bureau of Voids and Measurements. He kept both posts until he died. Mendeleev was also nominated for the 1905, 1906, and 1907 Nobel Prize in Chemistry for his primitive version of the periodic table. However, Svante Arrhenius, 1903 Nobel laureate, and many others favored other candidates, including Harry Moissan. Also, some other contemporary chemists speculate that Arrhenius might have rejected Mendeleev because of Mendeleev's critique of Arrhenius' dissociation theory and theory of ionic bonding in compounds. Further attempts at nominating him were stopped due to regulations surrounding Mendeleev's death, which occurred on February 2, 1907, 6 days from his 73rd birthday. His last words were to his physician, "Doctor, you have science, I have faith." With some of his humble origins and his different approach to science and his ultimate goals, to unite ancient Greek natural observations to the modern sciences. Mendeleev's work will be used and added upon to the present day, eventually evolving into the modern periodic table. His predictions will mostly come true as well. Gallium would be discovered in 1875, scandium in 1879, germanium in 1886, rhenium in 1925, and technetium by 1937. The noble gases, neon, argon, krypton, and xenon would all be found by 1898, filling in their spots in Mendeleev's chart. The extent of Mendeleev's work was immeasurable. It standardized the base of modern chemistry and organized the behavior of different substances and compounds, opening the door for new discoveries. Albert Ghiorso may have synthesized 12 elements, but without Mendeleev's periodic table, no one would know where to put them.